So welcome everyone to Container Runtime Intensifies. We are speaking about CRI-O today. I'm Sascha, one of the maintainers of CRI-O, and I really hope you all enjoy this beautiful KubeCon the next days. So what is CRI-O? It is actually a lightweight container runtime built exactly for Kubernetes. So means it's optimized for Kubernetes, and we also follow the Kubernetes release cycle. We implement the features directly for Kubernetes, but it's on the other side also OCI compatible. This means that we follow the Open Container Initiative, so if something changes there, it will also change in CRI-O. It's part of the CNCF since 2019, and we graduated in 2023, so we are still in party mood with respect to that. And we have more than 300 contributors all over the world, which is really nice, and it's still growing. So we are looking forward to CRI-O 133. So it will feature support for OCI artifacts, and on the other side we also have direct support for the image volume beta graduation, which will come in Kubernetes 1.33. Means we can then also support something like WebAssembly NRI plugins, and we also have some experimental FreeBSD support. And of course, I would like to highlight all those bug fixes, documentation improvements, dependency updates, deprecations and cleanups. I think that's a huge shout out to everyone who maintains this project. So thank you for that. We are really looking forward to the bright future of CRI-O. Let's look at the OCI artifact support. CRI-O is now able to pull artifacts into a dedicated storage side by side to actual container images, and this means that we can also list, inspect, and also remove artifacts now. This is completely new, and we can also, on top of that, we can use artifacts as image volumes. So this enables a huge amount of AI and ML use cases, which we all look forward that you show us how you use the feature. But it also allows configuration distribution for smaller artifacts and stacking the content of container images. So if you have a universal binary, for example, in a container image, then you can reuse it in multiple images by just using an image volume. So let's just provide a small demo of that. You can now use CRI-Cuddle to, for example, pull a seccomp profile, which weren't able before. So a seccomp profile is just a JSON blob in a single file, and CRI-CTL will tell you that the image is now up to date, but CRI-O will indicate that it's actually identified an artifact and pulled this artifact into the local storage by using their corresponding config media type and also manifest MIME type. Now, if you do something like CRI-CTL images, then you see that the artifacts are listed side by side to all container images you have locally available on the node. And you can also inspect them. So if you run CRI-CTL inspect image and then do this on the container artifact, then you get the status, the information, every metadata which is available for this artifact. Now, if you use an image volume like this, so you just create a Kubernetes pod, use BC5 volumes, the name of the volume is seccomp profile, and reference the artifact from the registry, and then mount it to the actual container, using volume mounts, and then reference the name seccomp profile, and then the mount path volume. Then you can create this pod, and you can exec into this pod, and you will see that on the path /volume, the seccomp profile JSON is available. And if you exec the pod and just look what this file contains, then it's you have the actual seccomp profile available in the local container. And this is our maintainer request to all of you. If you would like to play around with that, and if you have a use case in mind, then please come to us and tell us that, because we are really looking forward for future use cases to make CRI-O even better with respect to that. And artifact handling is still experimental, but we really look forward to your feedback for that. So thank you all, and enjoy this KubeCon.